Hello and welcome to this lesson on Entity Relationship Diagrams, ERDs. We're also going to be looking at indexing and features of a good visual interface. In this lesson we'll look at how to create an ERD, see why indexing helps make a database more efficient, and look at examples as to what makes a good visual interface. Entity relationship diagrams, data flow diagrams, flowcharts, pseudocode are all classified as case tools and are used for design purposes. Entity relationship diagrams are used to create efficient, error-free databases. If a database is well designed, normalization will not be needed. On this slide you see a typical ER diagram. An ER diagram, as I am sure you remember from your Year 11 course, is made up of four elements. The rectangles are the entities. These represent the tables in the database and contain information on people, jobs, or virtually anything. An entity's name should be singular, like band, album, and track. The diamonds show that there is a relationship between one entity and another. The word inside the diamond describes what the relationship is. The 1 to M is an example of cardinality. Cardinality describes the type of relationship. It can be a 1 to 1, a 1 to M, M meaning many, so it can be a 1 to many, as in this case, many to one, or many to many. We will look at cardinality in more detail later on. Finally, we have the ovals, which contain the attributes and are connected to the entities. These attributes can be written to the side or underneath the entity. An example in the pictures is the album entity, which has 4 attributes as part of this relation. Please take note that to get points for correctly drawing an ER diagram, you must circle the attribute names and have a line for each attribute connecting to the entity. Still using the same diagram, let's have a closer look at the attributes. In order for these tables to have a relationship of any sort, they need to be linked. In the ER diagram, you can see primary and foreign keys. Just like when we wrote out the tables in normalization, we show the attribute, which is the primary key, as an underline. The foreign key with an FK after it will always go to the many side, shown by the letter M. To remind you, a primary key must contain unique values, so each row, tuple, can be identified. Usually this unique identifier is a number of some sort. A foreign key is the primary key in a different table and is used to connect the tables. The content in the foreign key must be identical to the content in the primary key. To ensure this occurs, referential integrity needs to be applied to the database. You will get experience of using referential integrity during your practical work. In this picture, there is no example of a composite key. You will remember that a composite key is made up of either 2 or more primary keys in a table, or 2 or more foreign keys in a table. It is this combination of these 2 or more keys within the table that produces a unique identifier. In our previous slide, we saw an ER diagram with 1 to many relationship, written as 1 to M. The foreign key always goes to the many side. If the foreign key was placed on the one side, the resulting database would have duplicating data, which would be an insert anomaly, but would also create data redundancy and cause the database not only to become inefficient, but open to the possibility of having update and delete anomalies. In a one-to-one cardinal relationship, it does not matter which side the foreign key is placed. In this ER diagram, you will see that we have two relationships, a many-to-many and a many-to-one. First thing to note, when you write a many-to-many relationship, it is written as M to N, not M to M. A many-to-many relationship is not something you want in an ER diagram, as this would lead to data duplication when the database is made. So you always want to resolve a many-to-many relationship. Resolving a many-to-many relationship means turning this into two one-to-many relationships. To connect these two one-to-many relationships, we use what is called a linking entity, in this case called class list. It is important to remember that the many side is always next to the linking entity. Your linking entity, like class list, will always have two M's either side of it. The foreign key is placed on the many side. This new class list entity has been given a primary key called class list ID to enable each record to be accessed. In this example, we see a many-to-many relationship which needs to be resolved. To do this, we again need to create two one-to-many relationships which are both connected to a linking entity. In our solution, you can see the two one-to-many relationships and the linking entity called book/author. There are two features I want you to take note of. Firstly, the name of the linking entity. In a previous example, we made up a name for the linking entity, which was, as you may recall, called class list. In this example, we have created a name by combining other entities' names of author and book to create book/author. So it reads that one author writes many books and one book is written by many authors. The second feature to take note of is what is used as a primary key for the book/author entity. In our previous example of class lists, this entity had a primary key created called class list ID. In this example, we have a composite primary key for book/author made up of two foreign keys called author ID and ISBN. The method of how you resolve a many-to-many relationship, either using a primary or composite key, is up to you. However, it is better practice to use a composite key for linking entities. The naming of the linking entity is whatever works best for that given situation. Remember, a well-designed ER diagram will create an efficient database using optimal storage, correctly formatted data which only needs to be entered once, and information that can be quickly searched due to the database not having any duplicated data. Once the database has been built, further methods can be used to speed up the searching and sorting of information. In this image, you see a table in Design View. The field Zip has been selected, and in the General tab you see lots of features associated with this field. One of these features is the one highlighted called Index. By turning this feature from a no to a yes, it allows the Zip field to be searched and sorted more quickly, and duplicated data is not allowed in this field. In the Design menu, you will see the Indexes icon. By clicking on this, you will bring up a special view showing all the indexes created in this table. A primary key is automatically indexed. Whether designing a data flow diagram or writing pseudocode, creating an ER diagram involves learning and practicing a series of steps to ensure that you don't miss anything and that all the points on offer for a question can be gained. Over the next few slides, we will work through how to turn a passage of text into an ER diagram. Here are the 10 steps you need to take to create a fully resolved ER diagram. Step 1. Identify the entities. This is about seeing what roles, events, locations, persons, even ideas can be made into a table to be stored in them. Step 2. Find relationship. This is looking to see which entities will link to each other. The best way to do this is using a relationship matrix. Step 3. Draw a rough ER diagram. Here we simply draw in the entities and the relationships. Step 4. Fill in the cardinality. At this stage we need to determine what type of relationship we have, i.e. one-to-one, one-to-many, many-to-one or many-to-many. Step 5. Define the primary keys. Here we identify or create a primary key for each of the entities. Step 6. Resolve issues. At this important stage, we need to resolve those many-to-many relationships and turn them into one-to-many relationships. Step 7. Identify attributes. This is where we name the fields which will be part of this ER diagram. Step 8. Map attributes. Mapping attributes, at this stage we match what attributes we are going to be in which entity. Step 9. Draw fully attributed ERD. At this point we may need to draw and redraw our diagram and to consider the entities and newly created relationships. So at this stage, step 9, don't be afraid to rub things out and start things again. But we need to make sure that our ER diagram follows all the rules. Step 10. Check the results. Here we look at our finished ER diagram and we ask ourselves the question, does the ER diagram accurately depict the passage of text or system data? Let's read the text that will be turned into an ER diagram. A company has several departments. Each department has a supervisor and at least one employee. Employees must be assigned to at least one, but possibly more departments. At least one employee is assigned to a project, but an employee may be on vacation and not assigned to any projects. The important data fields are the names of the departments, projects, supervisors, and employees, as well as the supervisor and employee number and a unique project number. The entities in this system are department, employee, supervisor, and project. One is tempted to make company an entity, but it is a false entity because it has only one instant in this problem. True entities must have more than one instant. We construct the following entity relationship matrix. We need only to enter the relationship once. So for example, a supervisor runs a department. It does not need to be entered a second time. We connect the entities whenever a relationship is shown in the entity relationship matrix. So in our diagram, you can see that an employee works on a project. An employee is assigned a department, and the department is run by a supervisor. From the description of the problem, we see that each department has exactly one supervisor. A supervisor is in charge of one and only one department. Each department is assigned at least one employee. Each employee works for at least one department. Each project has at least one employee working on it. An employee is assigned to none or more projects. As you can see, we're going to have a problem, as there are two many-to-many relationships we're going to have to resolve in a short while. The primary keys are created. These are being department name, supervisor number, employee number, project number. As you know, we have two many-to-many relationships in the rough ERD between department and employee and between employee and project. To resolve this, we have used a linking entity for both of the many-to-many relationships. We now need to identify the various attributes. The only attributes indicated are the names of the departments, projects, supervisors, and employees, as well as the supervisor and employee number and a unique project number. We then place these attributes in the appropriate entity using a simple table. We now need to draw the full ER diagram table, showing the entities, relationships, cardinality, and all of the attributes, including the primary and foreign keys. Once the completed ER diagram has been drawn, it's important to go back and make sure that the ER diagram accurately shows what the text says, and that all of the ER diagram rules have been followed. Up to this point, we have looked at how to design our database, making sure that we have the appropriate entities containing the correct attributes and being linked correctly to other entities. So once our ER diagram is correct, we can start to build our relational database. However, design considerations should also be made for the visual interface. The visual interface looks at how a user will be able to use the switchboard, tables, and forms within the database, and how the user can easily and faultlessly enter the information. To produce an effective database, the designer needs to think about 4 factors: readability, navigation, logical order, and inclusivity. We will look at each one in turn. The picture on this slide shows good readability. The font type is clear, being sans serif, which is essentially just plain looking text. The font size is big enough to read with ease, and there are large buttons, which can be both seen and easily clicked. On this picture, navigation is made easier with the use of tabs at the top of the form. There are a series of fields that have drop-down menus, so the user can put in specific information. The tab key can be used to move across different fields, and a help comment is available should the user require it. This form is a good example of logical order. Here the fields have been grouped in a logical way. So we have a personal details section, mileage section, and tax applied section. The fields within each grouping are placed in a logical order. Finally, inclusivity, which is mostly used in the design view for tables. In our first image, we see that the description field has been used to provide information about the type of data that may be entered. Appropriate defaults, in this case field size, has been entered to ensure the overall size of the database has been reduced. In the second image, appropriate validation rules have been entered along with an error message if the data has been entered incorrectly. So any number less than a 0 will cause the validation text to be shown saying price can't be a negative number. That concludes our discussion on database design in this video. Now you will need to go and practice several ER diagram questions so that you are confident in answering these questions. Thank you for watching this video. Bye-bye.